Welcome back to my channel. I'm here with another video. We're doing physics, October November 2020, 5054, variant 1 2. Let's begin. A heavy nail is fixed firmly to a wall. It is pulled by a string at 40 degrees Celsius to the vertical. The nail does not move. Three forces act on the nail: the weight, the tension T in the string, and the force R exerted by the wall. Which diagram drawn to scale represents three forces? Okay, so if you read the question again, you're gonna see a very important sentence: the nail does not move. That means that these three forces acting are balanced. So these three forces are balanced. We know we have two methods. One is head to tail, and the other is parallelogram method. So out of these four diagrams, the one which is obeying these law out of these two will be the true representation of these three forces. So for example, if the weight is acting in this direction, then as we know, the other force should be the tail of the other force should be meeting its head, and this is how it should be, the parallelogram method. So this looks like the answer because the weight is acting in this direction, then the tail of this is attached with the head of this, and so it's gonna be look like the parallelogram method. In this, these two heads are meeting, which is not nice. And here again, two tails are meeting, wrong. And again, two heads are meeting, again wrong. So it has to be something where the head of one force has to meet the tail of the other force, and so go on. So this is A. Moving on towards question number 2. A car begins to move. It speeds up until it reaches a constant speed. It continues to travel at this constant speed for the rest of the journey. What happens to the acceleration and what happens to the velocity of the car during the journey? So what do we know? This is something really important. We know that initially, when it begins to move, that means it speeds up until it reaches a constant speed. That means there was a resultant force acting on the car that caused it to move. Right? So if I have what Newton's first law states, that if there is an object, it will continue in a state of motion or rest unless a resultant force acts on it. So I know if it was moving at a speed of 20 km per second, for example, 20 km per hour, then it will continue. If it was if its velocity is not changing, if its acceleration is 0, then it will keep moving at this speed. But it's not, because they're saying it speeds up until it reaches a constant speed. And we know reaching a constant speed means that initially first its acceleration increases, so then gradually air resistance increases and it reaches terminal velocity, something that we talked about initially as well. Now we said initially when something falls from a very great height, the only resultant force is its weight, and so it moves in the downward direction. But gradually, as the speed increases, the air resistance increases, and there comes a point when the weight and the air resistance, they become equal and the resultant force becomes 0. So when resultant force becomes 0, it starts falling at terminal velocity. That means both acceleration and velocity must have changed for it to reach a constant speed, because if it has to reach constant speed, then its acceleration has to decrease, its velocity has to increase. So this looks like the answer. You just have to understand the fact that this is something, I think in the second chapter, which is clearly written that when something falls from a very great height, initially its acceleration and it decreases because the resultant force decreases, because its air resistance increases as the speed increases. So both of them are changing for it to reach the constant speed. The speed time graph for the car's journey is shown. During which part of the journey is the car moving with a non-uniform acceleration? So let's look at A. What is A? A doesn't look like the answer. Why? Because A is just a simple line. It's saying non-uniform acceleration. This is a speed time graph. B is a straight line. That means it's constant velocity. C is non-uniform acceleration. D is non-uniform deceleration. This is wrong. The C is the answer. Now question number 4. A car is traveling forward at its high speed. The brakes are applied and the car skids along the road surface. In which direction and where does the friction force act? So we know friction always opposes the motion of any object. So if I have a car here, and it's moving in this direction, then the friction will be in moving in this direction, because friction is an opposing force that always has to act in the opposite direction of the that of in which it is moving. So it has to be backwards on the tire. Moving on towards question number 5. A car of mass 800 kg has a forward acceleration of 2.5 meter per second square. A frictional force of 1200 Newton opposes the motion of the car. What is the driving force due to the engine of the car? This is very important. So what do we know? They have given me the mass. I can find the force, the weight through it. I have W is equals to mg. Now what is W? Something I need to find. 800 into 10, that gives me 8,000. So now the part that you have to understand is the driving force due to the engine. Driving force due to the engine means the frictional force plus the driving force, which is the one which we actually find. For example, if I'm saying, if I have a car here again, and they're saying there's a 1200 Newton force that is opposing this motion, and then we say, let's say we have 800 Newton which is causing it to move. So what is the driving force due to the engine? I'll add these two forces, because the engine gives the total force that is allowing it to move, but then gradually as its speed increases, the friction increases, and then it causes it to decrease this and all. So driving force due to the engine, adding these two forces. So I need the frictional force, that is 1200 Newton, and then I need to find the what I need to find. Okay, so if you see here, they have given me the mass, they have given me the acceleration. What do we know? We say F is equals to ma. What is F? Something I need to find. What is m? 800, and it's 2.5. What do I get? I get, if I multiply these two, I get 2000 as my answer. So 2000 is the resultant force. Now 2000 is this force. The resultant force is causing it to accelerate in the forward direction. What do we need to find? We need to find the driving force. Driving force is 2000 plus 1200, that gives me 3200. So this is the answer. Moving on towards question number 6. A satellite orbits a planet in a circular path as shown. It has a constant speed. There is a force on the planet due to satellite. In which direction is the force on the planet? Pretty simple. So what do we know? We know the reason why, if I have an object here and if there's a planet revolving around this, there's a centripetal force that's acting in this direction. So this force is acting in this direction, this will be acting in this direction, because according to Newton's third law, if this is applying force in this direction, this will be applying force in this direction, so it's B. A block is hung on a spring balance. The marker inside the balance is pulled down by the block. So what can we find out by this? We need to find the mass of the block in kg. Yes, the mass of the block in Newton. Newton, no. The moment caused by the block in, no. It's Newton meter. Mass is in kg, weight is in Newton. So this is the right option. Moving on towards question number 8. Okay, so there is an astronaut on a planet which has a gravitational field strength 1/5 of the value on the Earth. He hangs samples of rock from a spring balance designed to use on Earth. Each sample has a mass of 0.1 kg. The spring balance reaches 1 kg. How many samples of rocks are there? So this is quite a tricky question. If they're asking me how many samples of rocks are there, I cannot just okay. So the thing that needs to be, we know that the mass remains the same on planets, but this is not the point here. The point is stating that they're using a spring balance which was initially designed to use on Earth. So that means that masses are gonna change, because they are using spring balance which was supposed to be used on Earth, but they're using it on another planet. So that's gonna gradually, that's gonna obviously change the whole readings as well. So if I have one sample has a mass of 0.1 kg, then how many samples have masses of 1 kg? X is gonna give me 10. That we cannot just cross circle 10, because we have to find the number of samples of rocks which were measured on another planet, not on Earth. Masses, it's a fact that mass does not change no matter where you go, no matter where on which planet you go. But the thing, they're using a spring balance, and spring balance was designed to use on Earth, but it's not being used on Earth, it's being used in another planet, so that's going to give me different readings. So on Earth there are going to be 10 samples, but on another planet, let's say I have W is equals to mg, right? So what do I know? I know the total mass is 1 kg. Here the masses are gonna be different, but the weight is gonna be the same. The force that's, so the thing is, it's like you can say, since this is quite a tricky question, let's make it simple. For example, I have a planet Earth, and then I have another planet called Mars. So I have 10 large steel containers, and they have the force acting on them is, let's say, 20 Newton, right? And they have mass of 100 kg, let's say. Now on Mars, I do not know. I know that the force acting is 20 Newton, but the gravitational field strength of Mars is different. So since the gravitational field strength of Mars is different, 20 Newton force will be acting on a different amount of steel containers. For example, if there were 10 large steel containers on which 20 Newton force was acting, let's say there are 5 large containers on which 20 Newton force was acting. So you see, so there's like the force remains the same, but the masses, they differ because its gravitational field strength was different. So I know 20 Newton is acting here, 20 Newton is acting here, but since the gravitational field is different, then 20 Newton is acting on 5 containers, and that same 20 Newton force is acting on 10 containers. So similarly, if I have W is equals to mg, if I have mass 1 kg and gravitational field strength is 10, it's gonna give me 10 Newton. Now 10 Newton is gonna remain the same, and now mass is something I have to find, but the gravitational field strength is different, and that is 1/5 of the value of the Earth. 1/5 of 10 is going to give me 2, so it's going to give me 2. So now what do I get the mass? I get 5 kg, right? And now what we need to do is that if one sample has a mass of 0.1 kg, then X samples have a mass of 5 kg. So it's 0.1 X is equals to 5, and X is equals to 5 divided by 0.1, that gives me 50. So it's 50 samples. So the thing that needs to be noticed here is that on 50 samples, a force of 10 Newton is acting, and that same 10 Newton force is acting on 1 kg as well on another planet. An electrically charged plastic ball is at rest. Which types of fields are caused by the ball? So an electrically charged, so since it's electrically charged, then it has to be electric field and gravitational only. Gravitational has to be there no matter what happens, right? Because obviously whenever something reacts, everything has a force pushing it with a force called gravity. So it's gravitational force and electric force. So when the current is moving, for example, electrically charges, they are moving, that's when magnetic fields are gonna be produced. Charges at rest have electric fields around them. Moving charges have magnetic fields around them. Which list contains only quantity that can be changed by a force? Mass can never be changed by a force. Shape, velocity, volume, yes. So it's D. An extension load graph is plotted for a spring. Which point marks the limit of proportionality for the spring? Now, limit of proportionality is that point after which the relationship between extension and load is no longer linear. So it's B, because after this you can see there's a bend. So as long as the line is flat, that is the limit of proportionality. When it starts bending, it's no longer proportional. Moving on to question number 12. The diagram shows a diver 20 meters below the surface of a lake. The total pressure at this depth is 3.0×10⁵ pascals. An air bubble has a volume of 0.60 centimeter cube as it leaves the diver. It rises to the surface of the lake where the pressure is 1×10⁵ pascals. The temperature of the air, it remains constant. What is the volume of the air bubble? So, as I told you initially, is that if they're asking me for the pressure of solid substances or anything, that's going to be equals to F over A. If it's about liquid, it's gonna be rho Gh, and it's usually when it's about air or like anything, it's gonna be P1 V1 is equals to P2 V2. So pressure 1 that was acting initially the total pressure at this depth is 3.0 10 raised to the power 5. So it's going to be 3.0 into 10 raised to the power 5. Now the volume that was acting, initial volume 0.60. And so what is the pressure which is acting on the surface? It's 1.0 into 10 raised to the power. And the volume is something that we have to find. So when you solve this, you're going to get 1.8 centimeter cubed as the volume is going to be this. A ball is dropped from a height as shown, ignoring the effects of air resistance. Very important line, when there is no air resistance, the total energy is going to be the same whatsoever, because as there is no air resistance, there is only going to be one force that's acting, and that is gravity. So it's going to be same at all points. Question number 14. A student uses an average force of F to push a box of distance d across a horizontal table. The mass of the box is m and the gravitational field strength is g. How is the work done by the student pushing the box is calculated? So pretty simple. What do we know? We know force work is equal to force in distance. Now, distance has to be traveled in the direction of the force. So if I have the average force of F to push a box of distance d, that means if this is a box and there's force F acting on it, and the distance being traveled is in this direction, so it's going to be F into D. A workman rolls a barrel of weight 2000 Newton up a plank of length 2 meter and onto a lorry. The back of the lorry is 0.80 meter above the horizontal surface of the road. What is the work done? Again, work is force into distance, and the distance traveled should be in the direction of the force applied. So they have given me the weight. Now where does weight act? Weight acts in this direction. So let's see the distance that is, has the same arrow as this. This is the distance. It's gonna be work is equals to, so it's gonna be 2000 into 0.80. Let's calculate this. We have 2000 into 0.8. That gives me 1600. What is power? Now what do we know? We know power can be energy over time or work over time. Force per second? No. The maximum force on object is the total energy, work done per second. Work done per unit time or per second. Question number 17. The diagram shows a glass tube filled with water and suspended above a bench. The water is free to circulate around the tube. At point P, there is a convection current moving in a downward direction. That means if it's moving in downward direction, the water has to be heated in the upward direction for it to move up, and then and all. At which point so we know whenever we heat water, it starts moving in upward direction. So if we heat at A, the water, it will, the water particle, they will expand and they will start moving in upward direction, and this is how it will cause it. So A can be an answer. Why not C? Because if I heat water, I don't know where it will go, it won't go down, that's for sure. D, water will start moving up. So these two are wrong. B, if I have to heat water has to move upward and not in this direction. Which physical property cannot be used for the measurement of temperature? Okay, so we need to find for the measurement of temperature the length of a metal bar, the mass of the plastic block, the pressure of a gas, the resistance of a wire. So it's about, so whenever we increase the temperature, expansion can occur. That can change the length, that can change the pressure, resistance. All of these things, they can be changed by changing temperature. We know resistance increases when temperature increases, and when pressure increases, when temperature increases, pressure decreases, and when temperature increases, the length increases because expansion occurs. But the mass, it does not change whatsoever. A student performs an experiment to find out how much energy is needed to change the temperature of a steel by 1 degree Celsius. Okay, so the definition itself is written here, how much energy is needed to change the temperature, that is heat capacity. Why not specific? Because they haven't told me the certain mass needed to change. Moving on towards question number 20. A substance has a melting point of minus 17 degrees Celsius and a boiling point of 117. In which state does the substance exist at minus 10 and 110? Pretty simple. So there is a simple trick to it. If I make a line here, I'm going to have melting point here, and I'm going to write boiling point here. At this stage, it's going to be solid. At this stage, it's going to be liquid. At this stage, it's going to be a gas. So I'm going to write solid. liquid and gas. So the melting point is minus 17 and it's 117 at minus 10. So at minus 10 has to be somewhere here, right? Because when we write a number like minus 1 minus 2 minus 10, it has to be, so it has to be a liquid at minus 10, and 110 has to be below here, so it has to be liquid. See, which description of a liquid is correct? It has fixed volume but no fixed shape. It is a very important fact about liquid because they have fixed volume but they do not have a fixed shape. A mass of gas is trapped inside a cylinder by a moving piston. As the piston moves in, the volume of gas decreases but the temperature stays the same. What happens to the gas pressure and why? So when the temperature stays the same, when volume decreases, pressure increases because the molecules they collide more frequently. There are three things: pressure, volume and temperature. To compare these two, one has to remain constant. They have told me that the temperature stays the same, so we have to see the relationship between these two. Volume decreases, pressure increases. Moving on to question number 23. A plane mirror on a vertical wall forms an image of an object placed in front of it. Which characteristic describes the image? So whenever we have vertical, we have a mirror. It forms same size, upright, real. No, it's not real. Virtual, upright, and the same size. Which statement about light passing from air to glass? It is from a rarer medium to denser medium. The frequency remains unchanged. The speed of the light waves decreases. Yes. So we know whenever something is entering from a denser to rarer medium, the speed increases, wavelength increases. But when you're entering from a rarer to denser medium, the speed decreases as well. Applications use different components of the electromagnetic spectrum. X-rays can be used in the three functions. High wavelength one, they can be used for radiotherapy, or they can be used in airport security, or medical imaging as well. Ultraviolet can be used in sterilizing. I'm just looking at B. Where does sound travel the fastest? So sound travels the fastest in solid, then liquid, and then gas. So it's in solids. Now, a scientific research boat uses a pulse of ultrasound to detect a fish underneath it. A pulse of ultrasound is bounced from a group of fish 6,000 meters directly below the boat. The next pulse is sent out 2 seconds after the echo from the previous pulse has been received. The speed of the ultrasound is 1500 meters per second. What is the interval? So we know, whenever there is an echo and all, we use 2D over T. So what is D, which is 6,000, and I have to use 12,000 over T, something I have to find, and they have given me 1500 the speed, right? So if I use this formula and if I divide 12,000 by 1500, I get 8 as the answer. But this is not the time. They're saying 2 seconds after. So that means if the 8 takes, they're adding 2 seconds more, which makes it 10 seconds. What should I correctly describe ultrasound? Ultrasound is a transport that has, greater than 20 kilohertz. Sorry. It's a sound. Sound is a longitudinal wave, which is. So it's a longitudinal and it has greater than. So it's B. My apologies. What is stored in battery and what is its unit? So we know chemical energy is stored in a battery, and energy has a formula. Unit is joules. A car battery delivers 150 kilocoulomb to a circuit before it needs recharging. 2 headlamps connected in parallel to the battery are switched on. There is a current of 4 ampere in each lamp. How much time passes before the battery needs recharging? So what do we know? Okay, so we know they have given me the charge, they have given me the current. I know I is equals to Q over T. So what is Q? Q is 150,000 and T is something I have to find, and I is 4 ampere in one lamp. There are 2 lamps in parallel. That means in parallel the current, they're gonna be total 8 currents, but if it would have been series, it would have remained 4. So if I divide this, I get, let's see, 1.5 divided by 8, that gives me this. These are seconds. I divide this by 3600 and I get 5.2, which is the hour. So it's speed. 31. Three identical lamps in 3 ammeters are connected as shown. The readings on the ammeter I1, I2 and I3, how are the readings related? Okay, so what do we know? We know that the current in this is the total current from the battery, so it's gonna be always greater than all of these two. So I1 is greater than I2 and I2 is greater than I3, because we know when something is connected in. Okay, so I1 has to be greater and then I2 has to be greater than I3. Reason being because these two are connected in series, and so they're gonna have total resistance greater than this. So when resistance increases, the current decreases, and so it's gonna have the less current. So it's gonna be 80. A thermistor and light dependent resistor LDR are connected in series. A potential difference of 6 volts is applied across them as shown. The thermistor has a resistance of 6000 in a cold room and 1000 ohms in a warm room. The LDR has a resistance of 2000 ohms in dim light and 500 ohms in bright light. Why is the potential difference equal to 2 volts? Okay, so I think the answer is C, and let me explain you why. So we know that in a warm room, thermistor has 1000 ohms, and in bright light it has 500 ohms. So now these two are in series. So how do I find the total resistance? That is 1000 plus 500, that gives me 1500, right? So they're asking me for the potential difference. I know in series the current remains the same, but the potential divides itself. But the total, I know V is equals to I, right? And the total potential is 6 volts. I is something I have to find, but the total resistance is 1500. So it's gonna be 6 divided by 1500. That gives me 0.004. So now 0.004 is the total current. So now total current, it remains the same in series whatsoever. So using this, I write this equation again, and let's say I take 1000. So now 1000, I need to find the total. I need to find the V that thermistor uses, but the total current remains the same. It's going to be 0.004 into 1000, and I get 4. So if this is 4 volts, and since they're connected in series, if these are 4 volts, then we subtract 4 from 6 and we get 2, so this is 2 volts. So it's C. Moving on towards question number 33. A 240 volt main circuit contains equal 860 watt lamps in parallel. At the time when the lamps are switched on, the filaments are cold and the current is 4 times as large as the final steady current. What is the initial current supplied by the mains? Okay, so we know P is equals to VI, right? Now power is 60 volt for one lamp and 8 is like 480. V is something 240 and I is something I have to find. So when I divide these, I get 2. So they're asking me for the initial current. That means that was 4 times, this is the final current, it was 4 times, it's going to be 8. What is used with the magnet to create an induced electromagnetic force in a simple AC generator? So obviously there has to be a magnet and there has to be a coil of wire which is through which the current is passing, and then there has to be a magnet. So it has to be a coil of wire. What changes kinetic movement energy into electrical energy? Okay. This is a wind turbine. Reason being because if there's a wind turbine, there's gonna be a motor in there which is gonna use the which is connected to a generator, and the when it moves with the help of a wind, it produces energy. A transformer has 4800 turns on its primary coil and 480 turns on its secondary coil. The primary coil is connected to a 240 volt AC supply. The secondary coil is connected to a lamp. How does the output current in the lamp compare with the input current? Okay. So you have to understand that when we're using transformers and all, the frequency remains the same. It's not about, we know, okay, so we know when we have step up transformer, step down transformer, that is used to change the voltages, but the frequency of the current always remains the same whatsoever, so it always has to be the same frequency. Moving on towards question number 37. A cathode oscilloscope with a Y gain set at 2 volt per division is connected to a generator. Which row describes the signal from the generator and its amplitude? Okay, so from seeing this, the shape of the curve, the wave, we know it's an AC supply, because if it was DC, then it would have been straight line. There wouldn't have been variations like this. It's an AC supply. Amplitude. So I know if this is at the main line. An amplitude is the maximum displacement point from its rest position. So this is 2 volts, the 1, 2, and then it's going to be 4, but it's going to be 3, so it's going to be 3. A potential divider uses a power supply of voltage 12 volts. The resistor X and Y initially have equal resistances. The resistance of X is halved. What is the change in the output voltage? So if we use this formula of V2 is equals to R2 over R1 plus R2 into total V, is gonna give me the answer of plus 2 volts. Moving on to question number 39. What is the definition of the half-life of a radioactive element? So now pretty simple. We know half-life is the time taken for half of the nuclei of that isotope to decay. So nucleon number to decay. Which row shows the atomic structure of the neutral atom with a nucleon number of 9? So it has nucleon number of 9. Then if you look at the product table, you're going to see it's P. Because it's a neutral atom, that means it's going to have the same number of proton and electron. This is the only option that's it. So it's 40. So this was the end of our video. If it was helpful, please subscribe. And if you have any queries about any question, then leave a comment.